This figure shows the potential versus the R graph. Okay, so they ask which position shows that the particle experiences zero net force. Okay, zero net force means F equals to mg equals to 0. F is 0 means G equals to 0. But how G is related to phi? Do you still remember G is actually equal to negative d phi over dr? It represented by the gradient. Okay, actually it's a negative gradient. Okay, negative gradient of phi versus the R graph, right? So in this case, you want G 0. The gradient must be 0. In this case, which part of the gradient is 0? Obviously, at point C, the gradient is 0, right? Okay, so like that, you can solve the problem. But I would like to extend your understanding in terms of graphical view of the strength and the potential. How do we draw the G versus R graph due to the Earth? Let's forget about the moon. Just cover the moon, forget about it. How the G versus R graph due to the Earth at this point? Okay, let's say this point. So what you should do, you just put a mass here. Okay, put a mass here and see how it goes, right? In this case, if I put a mass here, the mass will be attracted to the left, right, due to the Earth. So let's say we treat to the right as positive as usual because the R here, because due to the convention to the R is positive, right? So we usually use this convention. Since it's go to the left, so we say the G is negative because G is a vector. All right, vector has direction to the left. In this case means G is negative. Negative means from here has maximum G. Okay, maximum G. When it's go further away from the Earth, the G approaching 0, right? According to G equals to negative gm over R squared. So remember, when R increasing, G decreasing. So this one, just draw a graph like that. They never touch 0, okay? 0 means they were reaching infinity. Okay, now this is G due to the Earth. What about G due to the moon? Okay, let's talk about the moon. Now let's cover the Earth. Concentrate on the moon. Okay, what about this mass? This mass will be pulled by the moon to the right. Right, is G of the moon. So since to the right we say it's as positive. So in other words, when we draw the strength here, we should draw positive from the surface of the moon. So we draw a straight line here. Okay, this from the surface here. The G is positive. Positive means start from here. Take note that this G, the magnitude, this number cannot be bigger than this magnitude. Okay, cannot be bigger than this magnitude because the mass of the Earth is bigger. The strength is larger on the surface of the Earth compared to the strength of the moon surface here, because the moon surface, the mass of the moon is smaller. So the magnitude of the G is smaller. In fact, this is just G over 6 of the Earth. Right? This is G. This G is 9.81, whereas this is just 9.81 over 6. Okay, there are roughly this figure. So from here, how are we going to continue to draw the G at this side due to the moon? Obviously, when it's further away from the moon, they follow the same relationship. The G will decrease. Okay, but never touch 0. Now, following this, what about the resultant then? How can we draw the resultant G? Very simple. Just add up the number. Let's say this is G 9.81 over 6. What about this point? Then this high positive number plus the small negative number, you will get some resultant, right? Okay, let's say the resultant is here. Okay, let's say the resultant is here. So continue. This one, add this one, this point, add this point, something end up here, right? What about this one? Add this one. Wow, can you see this one and this one almost similar? So they might be 0. Then this one, add this one. This is slightly more negative. This is a little bit positive. So the answer may be a bit negative. So we do the same thing for the rest. So we will get the entire graph to look like this. Okay, the graph looks like this. Okay, maybe I should redraw this part. Okay, this one is just look like that. Okay, this is the G resultant. Okay, after that we need to extend this one, straight line here, extend this one. Now what about this? How do you draw? Why I purposely draw this one? Because we know that when the G is 0, you will get the highest point for potential. So in this case, how do we draw the potential? Very simple. Potential, we don't care. We no need to put a mass here. Potential is always negative. See, remember, potential is always negative because potential phi is negative G M over R. Is always negative. So for the Earth, so at the surface here is very negative. It's very negative because the mass is super big. For the Moon is also negative, but less because the mass is small. Less is small, so it's not so negative. But it starts from here. Very interestingly, they cut through this point. Okay, they cut through this point. They cut through this line here. So what is the resultant? So this one is phi due to the Earth. This one is phi due to the Moon. What about the resultant? The resultant, we just need to add up this negative plus this negative, you get more negative. This one plus this one, you get about this one. This one will be here. This one will be here. This one plus this one will be here. This one plus this one will be here. So in other words, you will get this graph. Okay, so this is the phi resultant. Take note that the highest point here, the least negative, is called the least negative. The G becomes 0. So look back at the question. So we'll be able to see that the answer is C, which can be solved by this simple formula. But the graphing analysis is very important. Okay.